We're streaming. And what do we say when the stream starts?
Make sure to like, comment, and subscribe.
That is what we say. That was buying time so that the website would update so you can see the JSON. Okay, fun fact. So, the first year I taught this class, my impression was we were not supposed to teach JSON. Last year I taught this class, I had Professor Lucas Cordova cover the JSON lecture because it was something I knew he'd be comfortable talking about, and it doesn't really, how you teach JSON doesn't really affect any of the rest of the class. So it was a good guest lecture. Professor Lucas Cordova was teaching data structures the next term at that time, and I was trying to promote student interest in data structures. I wasn't clever enough to do that this year. Professor Fred Ogbo is teaching data structures next term, which I would encourage all of you to take. Separately, while you're working on Enigma, maybe not the best time to pitch the next course in the CS curriculum, right? Like, maybe we want to do that, like, after the cupcake party or something, right?
You have a cupcake party?
We don't have a cupcake party, right? So that's why we're just not going to pitch it. So anyways, so really, I've been looking at JSON in actually all three of my classes this term. And so when I thought about making the JSON slides, I was like, why don't I make them using the style of slide I like that is more modern instead of the cringe one that I use for CS1, right? Because I was just using CS1 stuff from like 2021, and every time I go to update it, I like have to write a new class, and I'm like, ooh, yeah, right. So I also wanted to show you this. These are Cordo Markdown slides, which is newer technology than the last time I taught this class. It's less than a year old. I'm teaching it in my CC. We teach it in the master's program. It's kind of slick, so I thought I would make sure I at least show you one of these. Last year, right at the end of the term, I started doing Quarto Markdown slides in this class, and so I did like Quarto, Q-U-A-R-T-O. And the way to understand them is you have a link to this now and like fiddle around with the source code. You'll figure it out. You're smart people, right? So the slides look a little bit different this way, and I want to motivate that. I mean, this is a different way to present material. So today we're going to teach about JSON. Why are we teaching about JSON? Well, there's a lot of reasons to teach about JSON. We're doing sort of faculty candidate interviews right now, and they keep joining the call while I'm talking to one of my colleagues about JSON, and everyone's like, oh, JSON, that's the thing I use for, and then they like say whatever they do, right? So it's used for network analysis. It's used for data interchange. What is data interchange? The thing you use JSON for. It's used to set up configurations for devices and routers and networks and so on. It's also used in the project after Enigma. That's right, there's another project after Enigma, right? I knew you were getting worried that we were going to end on Enigma and then you'd have like the bad feelings. So we have another project after Enigma that's about like going for a nice walk in a meadow, right? That's what it's about. And you'll love it when you get there because everyone loves JSON. What does JSON stand for? JavaScript Object Notation. No relation to Java. Java is unrelated to JavaScript. I'm not teaching you Java. I'm not teaching you JavaScript. But there is this little thing called JavaScript that lives in the world that we live in. I think if I like inspect this page in Firefox, I don't know how you do it in Chrome. There's a very, very tiny box here at the bottom of the screen, and I bet I can't make that bigger. Oh, I can! I'm embiggening it. That's not what I was going for. We're going for this. And there's a little console here that lives inside your web browser. That's kind of cool. What are some things we can do in that console? Can I make a list of integers just like in Python? Wow. Can I make a dictionary just like in Python? Wow. No? I would have thought that was going to be a yes. Guess not. Ooh, I wonder if I can put like, I don't know. I thought I could do this. Oh, I'm doing the wrong quotes, I think. Anyways, there's like a whole programming language in here, and I don't really know it that well. But you can do like hello world. You can add numbers together. You can create a list, or we'll call it an R. It's going to be 1, 2, 3, 4. And then you can probably like append to that or something. See if this is true. It's not. Push. That one just worked, I guess. Yeah, okay, so miraculously you can push things onto arrays inside your web browser, right? Anyways, this is JavaScript. This is what all the code in the world is written in. There's only two programming languages left. They're Python and JavaScript. Few differences between Python and JavaScript. True is lowercase, false is lowercase, and they don't have none. They do have null. That's pretty much it. There's not really a lot of other differences. So it so happened that this JavaScript object notation looks an awful lot like lists and dictionaries in Python. So you get to think of it as lists and dictionaries in Python, and then you also know JSON. And JSON is cool. It's lightweight. Compared to what? I don't know. It's definitely heavier weight than plain text, but it's also less ambiguous, right? So in JavaScript, there is never the it's time to eat grandpa problem that we have in English, where like if you put a comma in the sentence somewhere, it changes its meaning. It's inherently hierarchical and totally unambiguous, so that's kind of nice. You can read it as a human, though generally speaking, humans are not reading JSON. It is extremely common, and it is language agnostic. It does have JavaScript in the name, but I am not aware of a language that does not support JSON. Some of them support them different ways. The sort of core thing that happens with JSON is serialization and deserialization. And deserialization is when you ate cereal for breakfast and then you can't hold it. Okay, sorry, that's not. Okay, so serialization is when things are in a row. So serial as the negation of parallel, things being next to each other. So when we take a Python data structure, let's open Viz Code, our most beloved Viz Code. Let's see what we had open in there. We were doing Enigma. That's fine, I guess. Other.py. So I can make a list. I'm going to call it x's. And I can also make, I don't know, some other lists. Let's do 2, 4. Why am I writing this manually? And then z's will be list range 3, 12, 4 or something. Does that sound right? I don't know. And then I can create a dictionary that's going to be x is going to take on the value x's, y is going to take on the value y's, and z is going to be the key for the value z's. Let's see, get all my punctuation correct. A lot of people don't know this, but the point of computer science is just to write a bunch of punctuation correctly. That's a common misconception that it's something other than that. Ooh, we tried. Oh, I spelled y's wrong. Okay, so there's a few ways to look at this, but one of them is that, well, I have this Python object, and I would think of this Python object as having some hierarchy, right? I would say at top level there's x's and then x, y, z, and then down below that there's the lists, and then within the lists there's some other structure. But you can just print that whole thing out as a string. And with the use of all that punctuation we put in, that string is going to represent the same information. So this is serialized, okay? But if I serialize this, and I just put it back in Python, then I'm still able to look up values in thing x 0, and I can still print that out. So I'm able to go in between something just being a string representation and it being some sort of structured data representation. And so serialization is turning into string, deserialization is turning back. We claim that this makes complex nested data easy to handle. I think I would weaken that claim slightly, which is that this is a way to handle complex nested data. There's not really a lot of competing ways to do it better. So a lot of times people reach for this as a tool when they have something that isn't going to fit basically in a CSV file or data frame. So I was going to teach this originally in the context of scientific computing, and then I was also going to teach it in my sort of upper division class as a way to store the changes made to a document. So when you change a text file, you can view that as an array of lines of text, and then you can put those arrays of lines of text inside a JSON file. And then if someone only changes one line, it's very easy to note that there was a small change. You don't have to save 2 entire copies of the text file. And this is the basis of a lot of, well, that's how Git works, right? You can also think of this in terms of the periodic table of the elements. Folks, who loves the periodic table of the elements? Okay, I kind of expected that to be everyone. You are aware that you're all made out of atoms, right?
Yeah.
And there's pros and cons to that.
Mm-hmm.
Mostly pros.
This is true.
Mm-hmm. So we love atoms, right? And what is on the periodic table of the elements? Atoms, right? So by the transitive property, we love the periodic table of the elements. Everything you love is made out of atoms. Things like love, beauty, art. Okay, those are bad examples. Well, okay, so there's the physical representation of art, right? But that's distinct, you know. Yeah, creativity is made out of atoms, right? Because it's in my brain, and my brain's made out of atoms. Or, yeah, would you have a good one? Okay, here's something made out of atoms. Alien, the Alien film, right? Not only does the film medium is made out of atoms, but they were filming atoms. So it's a recording of atoms on atoms, right? That's like 2 atoms. That's probably more than 2 atoms, right? It could be considerably more than 2 atoms, right? So anyways, if you're trying to store the periodic table, maybe one way to do that is JSON, right? So I like to make strong universalizing claims about my experience, which I think is completely general and also applies to everyone else. There are exactly 2 universal structures. There's the dictionary, which is the key-value pair. 2 examples I came up with is you can relate states to state capitals. And fun fact, you can do this whether you mean U.S. state for state or nation state for state. And in fact, in some cases, you can have the same state. So Georgia is both a nation state and a U.S. state. Big ups for Georgia, right? I wouldn't have thought you could pull that one off. Then you can also do zip code to state. So for example, when I buy gas, I have to remember what zip code I live in. And the existential terror grips me. But using my highly attuned scientific mind, I'm able to remember of all of the zip codes I've ever lived in that I'm on this side of the country, I should select the one that begins with 9, right? And so that's a way that I use data to buy gasoline. A thing that I love to do. Okay, and then there are also lists. Those are ordered collections of values. I don't know who put that parenthesis at the end of that line. There's a lot of mysteries about who does things to my slides, right? But anyways, these were definitely not generated with Google Gemini. So I'm not going to blame the large language models there. Who loves to cheat on their homework? That's great. Yes, good job. None of you are supposed to say that. I said, yes, I'm cheating on my homework.
You used Google Gemini?
I used Google Gemini, and then it wasn't very good, so I changed all of it anyways.
Calvin.
What?
I'm disappointed in you.
What?
AI is bad.
No, Google's bad.
Yeah.
Okay, both of them.
The AI is probably fine. We just don't have separation between it and tech companies, right? The transformer technology is objectively, potentially cool.
Very potentially.
The usage?
The usage is cringe, right?
Yeah.
So what did we learn here? It's fine to learn computer science. You just can never use it for anything. Right, yes. Right. Like, doing computer science is inherently evil. Knowing computer science, that's fine. Right, okay. Yeah. Is that what am I teaching this term?
CS is evil, or applied CS is evil.
Yeah, something like that. Okay. Anyways, so the other way to store things is an ordered collection of values. And the classical example of an ordered collection of values is, I don't know how old any of you are, but when I was like very small, there was this physical medium called paper, and sometimes people it was stackable. So sometimes people would have more than one. They usually called them pieces or sheets of paper, and because they exist physically in 3 space, you could put them in different arrangements, but they inherently had to be ordered, right? Because there was no way in physical space for them to be in no particular order at all, right? And so that is an example of a naturally occurring list, right? And then even more silly people, they took dictionaries and they wrote the dictionaries down on the paper, which meant that you can use a list to implement a dictionary, and that's how computer science was invented. Okay, so dictionaries, you know what these are. Do I need to go over dictionaries again?
Nope.
Okay, cool. I should say one thing. I don't know what you're hearing from your section leaders and quad tutors and stuff. My understanding is what I'm calling milestone 0, key pressed, key released, and is key down, which I'm guessing you're all done with. The original version of the instructions I read, you were supposed to use a dictionary to do this. Have you heard this? So the original, this is, okay. Obviously there's one key down at a time, right? So I thought, you should store the key that is currently pressed down, right? That's what I thought. Apparently that was incorrect. The actual correct way to do this is to create a dictionary of all of the keys. Not a list, because the keys could still be ordered, right? So you create a dictionary of all of the keys, and then you store whether they're pressed down or not. Right, this was quite surprising to me. So I wrote my own instructions for this. But anyways, wait, I saw no longer depressed, and my mind went to a different place other than where it was currently. And so anyways, while this assignment is intended to teach you classes, it was also intended to teach you dictionaries. Wait, did we go back to the beginning here? Oh, no. It's over here. Okay. I call them hash tables. They're unordered. They contain key value pairs. What's going on there? That's pretty weird. Wait, this code actually ran. Like, I simulated this. Okay, that's like actually a JSON file. So do you all know what helium is?
Yeah.
I think it's like the second most popular thing in the sun. Does that sound right? You know, there's hydrogen and then there's the other stuff, right? And then like most of the other stuff is helium and then a little bit of it is iron, and no one that doesn't understand science, by which I mean me, really understands where all of that iron came from. But I guess that's why the sun is orange. Does that make sense? Does anyone know physics? Astrophysics? Okay, we'll ask someone who knows later and we'll see if I'm correct. Okay, now you can't just say what phase the Platonic ideal of an element is, right? You have to specify that it's at standard temperature and pressure, right? We all understand this. We all love standards, right? It's in group 18, it's in period 1. And, what is the boiling point of helium? That's a great question. I'm so glad you asked. What type of temperature do you use? Right, so here's a fun example. What did I do? I went and I put a dictionary. Oh, it's a dictionary. Oh, what's this? This is a dictionary that I placed within a dictionary. So it's dictionaries all the way down, folks. There's no way this code actually works. Oh no, it ran. Oh no, what happens if I print it out? Oh my goodness, the data that was previously hierarchical is now serialized. I feel like this was quite exciting, by the way. Okay, yeah. You will, at various points in your time, in your life, probably deal with JSON files. Here's an example of a JSON file. I'm going to save this as a JSON file. Am I going to do that? Yes. He.json. Oh, look! Syntax highlighting in VS Code, right? And I think not the same syntax highlighting as Python, because JSON and Python are different things, even though the characters are the same. Okay, so what can I do with this JSON file? Well, I can do a few interesting things. That's not at all what I intended to do. I can probably open the containing folder, and I want to open with Firefox. You can open these JSON files with your web browser. Can I get a gasp? Yeah, that was quite a gasp. Okay, and look, it is serializing. And what was that? Deserializing? Going back into the hierarchical form? I don't know. That's kind of cool. You can also look at the raw data. What's pretty print? Oh. I don't know what's changing. Oh, the indentation's changing. Yeah, I think it's telling me that I'm not pretty. Oh, this is cursed. When I click pretty print, it's making it thinner, right?
Whoa.
Yeah, so this is why AI is bad. This isn't AI. Okay, this is a web browser. Okay. Now, web browsers are separately bad, right? And why is that? Follow along with me. Fill in the blank Chrome.
Evil.
Okay, I was going to go with Google Chrome, right?
Okay.
Fill in the line blank Gemini.
Evil.
Right? It's Google, right? And so, what do Gemini and Chrome, both of which are evil, but only one of which is AI, have in common?
Google. Evil.
But we repeat ourselves, right? Okay. I have my JSON file. I can check to see if my JSON file is well formed. And I can do that at our most beloved command line. I remember something about you all liking the command line. I distinctly remember that. There was definitely a sentence that contains love and command line.
I love hating.
I knew there was something with loving. So what do? We're going to do mjson.tool. Wow, it's calling JSON a tool. And then we're going to do the file name key.json. Oh, look, it's the JSON file. Viewed all pretty printified. And I know what you're thinking. You're thinking, what's that do? No problem. I'm going to demonstrate what happens if this isn't JSON by destroying one of these parentheses. Oh, do you see how it all became red and angry? Okay. Now what's going to happen? Oh! They're expecting a delimiter, line 2, column 15. Okay. Are we back? We're back. Folks, we're back. And I put the semicolon inside of. So you can see that's how JSON works. Okay. Not everyone loves to do JSON in this manner, and that's okay. You can also do it with Python. So let's go ahead. I'm going to yoinkify this code. Is that a new one? Have I not been saying that all term?
No, I think that you should say it more.
So instead of copy paste, you can yoink and yeet, right?
Yeah.
Yeah. This is too much all at once, right? So blah blah blah. There it is. Okay. But what's going on here? Well, we have a file which is open file name. And we're going to print out what that is. Then we're going to read that, which is the contents. That is going to be f.read. Then we're going to print the contents. And then we are going to turn this into JS with json.loads contents. And nope, it's not js.loads, it's json.loads. And then we're going to print JS, okay? So what's going to happen each one of these steps? Oh, file name is not found. Real.
I think it just doesn't need quotes.
There's no way I just don't need quotes. Oh, here. Yes, no, that. Yes. Yes, no, yes. Yes, no. Okay. So what is the first thing? Panel position, right. Okay. Cool. So first we print f. Oh, we should print the file name first. And if I'd done that, then I would have known the quotes thing, right? So So, did this run? There we go. He.json, named after the sun's second favorite element, right? That, when we open that file, we're going to get an object of class _io.textio wrapper, which, as we have discussed in this class, makes perfect sense, right? It's going to be named he.json, it's going to be in read mode, and it's going to be using UTF-8 text encoding. Of course. What else would it be using? It's pretty much the only option. And then we can see the contents of the file. So this is how we read things as JSON. There's a pretty big difference between just the contents. This is perhaps serialized, deserialized, I don't know, depending on how you want to think it. If we look at just the contents, so I'm going to comment this out. It looks like this, right? It probably looks like a Python data structure, but if I query contents and ask it for the symbol, you can't do that because this thing is a string. You can ask it for the 0th thing, and it gives you, I don't know what it gives you. Oh, I'm not printing. Hold on. It gives you this bracket, this curly bracket here. And if I ask for the 10th character, it's going to give me probably something inside symbol. Yes, it gives me the B. That's because this thing, the file contents, is a string. It is not a Python data structure. When we json.loads, and then we print it out, then we can look up the JSON symbol. And this will now be meaningful, and we can see that it is capital HE. So, json.loads, if you print out what you're looking at, it will basically look the same. But one of them is a string, and one of them is the Python data structure. Okay. You can use this to look up symbols. You can use this to look up things. You're supposed to use get. You can iterate over. Let's iterate over both of these, actually. For C and contents, print C. For J and JS, print J. These are not going to be the same things. One of them is going to be every letter in the JSON file, and one of them is going to be the 3 keys. Or the 3 keys? There's 5 keys there. That makes sense. There are 5 keys in that dictionary, so that's why I would see 5 of them. I don't know what I thought the 3 were. Oh, I thought it was solid, liquid, and gas, and that's a completely different set of 3 things. Okay. There we go. Good job. You can use values to look at all of the values. js.values. Oh, you have to put parentheses at the end of it. There we go. What is that? What is that? One of the values of a key value pair in a dictionary is itself a dictionary. This is a dictionary inside a dictionary. I'm trying to emphasize the point that we can put dictionaries inside dictionaries. You all got this? Okay, I'm putting a dictionary inside a dictionary. It's fine. Nothing's breaking. It's just a little ugly. All right, okay. Cool. Then we can also look at items, which is everything. What are these little critters here? What type of thing is that? What is? I heard tuple. I liked tuple because this is a pair of things, and I cannot. It's not immutable. I can't change the insides. Comma separated. Parentheses delimited. There is a string and there is an integer in it. So that is a string integer tuple. Tuple. Tuple? Tuple. Rhymes with couple. Tuple. Did you say tuple? 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 You can put dictionaries inside dictionaries. I know you don't believe me. I keep hearing the sound of you not believing me. No problem. JSON.loads. open file, nope, no quotes, file name dot read. What happens if I don't put the read there? If I don't put the read there, this thing is a underscore io dot text io wrapper. That is utter nonsense. That doesn't make any sense at all. I need to give it a string. So I'm going to read it. And then we can look up key boiling point, which is probably like the name of a documentary or something. And what is our favorite temperature scale?
Celsius.
I was going to go with Kelvin.
Oh, that would make sense.
Yeah, wouldn't that make more sense?
Energy drinks are really yummy, though.
Wait, the Celsius drinks?
Yeah.
They taste like chemistry.
I think most things taste like chemistry.
That's the problem with taste, right?
Yeah.
Okay.
It's atoms.
But, well, I was going to say taste isn't atoms, right? We're chemorecepting aromatics, but the matter of having good taste does not exist atomically.
Very subjective.
Well, yeah, it's not my fault it's subjective. It's because it's not made out of atoms. Okay. We can also look up the Calvincius. And then we can also look up the Fahrenheit. Did I do that successfully?
Yeah.
Cool. There we go. Json. Json uses slightly different terms for these. Why? Just to be language neutral. A dictionary in Python is called an object in JSON, so they call them objects. They are curly brace delimited, and they contain keys and values. There is one special difference, which is that if I were to write this in Python and say, hey, string equals, can I do this? I might be able to read this directly. I'm going to try it. I'm just going to call it S. Actually, I think string might be used. Okay. Why does it say stop iteration? Okay, this thing, that's a text IO buffer, whatever. When I dot read on it, it turns into text. So if I put an S in here, the same thing should happen. I'm putting the same text, okay? Is it running? It's running. Okay, that still works, okay? So I'm able to turn this text into JSON. Now, in Python, I could also say key equals this thing. And that's still allowed, right? In Python, I'm also allowed to have single quotes. That's allowed. See? I'm allowed to have single quotes. If I do that in JSON, the universe explodes, I think. Yeah, see? See, I'm getting yelled at. I'm getting admonished. If I Python 3 mjson.tool, is it tool or tools? I'm not going back that far. We're just going to try it. We're going to see what happens. Tools key.json. Ooh, what's that? Do we see this? The computer has identified that I'm engaged in problematic behavior at line 2, column 15, which is probably right around here if I had to guess. See that? Okay. I'm engaged. I'm breaking the law. Okay. If we come over here, if we say JSON loads, open file underscore name dot read, doesn't work. Not allowed to do that. So, in Python, I'm allowed to use single quotes. In JSON, I am not. In many of the languages that make up the family of languages that use JSON, single quotes are used for individual characters and double quotes are used for strings. In Python, there is no different type that is a single character. So single and double quotes can both be used interchangeably. When you're using JSON, you got to use double quotes. I've been trying to use double quotes all term because I know those other languages, not because I was planning on this lecture. If you think single quotes are really cool, that's good for you, and you should stick to your guns on that. But when you're using JSON, you just have to remember to change over. Okay. JSON is named after the crossover horror film Freddy vs. Jason from... No, okay, well, we'll keep trying. From that, JSON's not in that one. It's named after Jason Derulo. Okay. It is extremely common to use JSON directly from a URL. JSON's awesome. And oh, what's this? The cool Helium JSON I'm working with. I put it on the internet for you because I care about you and I want you to be happy. That's why I did it, right? Look, that's a URL. You can just put that in your web browser. Oh, look, you can do this too. Why did we do that? Well, there's the super cool way to use JSON, which is using this little thing I like to call the internet, right? And the internet has the benefit of you can't put things on the internet unless they're true. So if you get a JSON file off the internet, that means you can trust it. Let me show you how to get a JSON file off of the internet. Okay, so do you know that they let me teach these classes? I didn't just like show up one day and like start teaching them like going rogue. Yeah, you can't trust things you learn in class. You trust big Marxist professor.
Yes.
Okay, I'll have to get larger, so I'm a big Marxist professor. Okay. Actually, so I started consuming an extra 15,000 carbohydrate calories a day, and I gained 7 pounds.
Wow.
Yeah.
If only I could trust you.
I know, right?
You should like post about it on your Twitter so I can trust you.
Oh, I don't post about that on my Twitter.
No.
Okay.
Maybe you should.
Maybe I should.
I think that you should just start teaching this class on Twitter so I can trust you. Because I just trust everything I see on Twitter.
So, fun fact. We're on... So, I don't know if... like, I guess I could live stream on X, the Everything app. Yeah. Okay, so we're going to take the URL. Which URL are we going to take? We're going to take the URL from the previous slide. Right-click.
Dun, dun, dun.
Copy link. You know what they say, a new Frank Green and a copy link. Have you all seen the Gen Z Boss in a Mini video?
No.
Okay, well, spend less time on the internet. Don't be like me. Okay, so I imported requests. Requests is a thing that we can import. Whoa! Just like JSON. We can even just print out what requests is so you can see it. It is a module. I'm going to move this to the bottom. Panel position, bottom. Do you know that it's actually possible to have a room with 2 projectors so you don't have to just cut your screen into progressively smaller? I'm doing the Fibonacci thing right now, where I'm just cutting it in half. Okay. You know, you can open a text editor down here and open, and then you can edit this, and then you can cut that in half into a terminal. Okay, sorry, I'm going to stop. I would like to reiterate that I'm normal. I am the normal one. Okay, so we can see the requests package. We're going to get a response. I'm going to say response is equal to requests.get URL. And then let's look at what response is. How did I learn you say requests.get URL? I looked it up on Stack Overflow. That is a response 200. I'm pretty sure 200 means it's Gucci. I think 200 is internet for Gucci, right? So if you have seen the Lady Gaga film House of Gucci, right? That was about the request setter. Okay, I'm gonna just stop referencing films. Do y'all watch like Kamen Riders or something? Shin Godzilla?
That's a good one.
That was a good one, right? Okay. Wicked?
No.
Yeah.
Oh, yeah, there we go. Yeah, you just gotta keep like iterating through the state space. Okay, print response. Okay. Then what are we going to do? We're going to say helium equals response.json because I'm going to JSONify it. Now, this JSON is different than the earlier JSON. This is a .json inside of a request. This is not the same thing as JSON.load, but it's still going to give me JSON back, okay? Then I'm going to print he, and I'm going to print symbol he, which is the 2 things I checked. Or he symbol. You may have heard of He from the hit series He-Man, which was about a person made out of helium. I thought that was a good one. Helium?
Good answer.
Good answer. Good answer.
Yeah, She-Ra was a Ra made out of helium.
Okay.
Which, so versus He-Man,
Is
it was
only
a...
when they transform that they become helium?
So you've now revealed you know a lot more about this than I do. What are we doing? Okay, helium. There you go. No! Okay. All right. So you can also do this with data that there is a lot of. So I'm going to do this with some vaccine data because there was a short period of time where people cared a lot about that. And then they stopped caring. Okay. Do you notice that my computer is being slow? You see that? Here, I'll do it again. Okay. Or I don't know. We'll just print like some text like YOLO when we're done. Okay. 1, 2. That was kind of slow, and that was much faster the second time because it was all warmed up and ready to go. Right. So this is a big file. Slow. Okay. So don't try to print out this whole thing.
This is fun.
This is like when
You got to check the other wrist too to make sure you don't have imbalances in your shoulder harness.
Yeah.
Oh, it's still going. Okay.
Yeah.
So instead of doing that, let's do something that makes a little more sense. Here is one way you can investigate JSON files, okay? Follow me through here. Okay, I'm going to create a local variable. It's going to start pointing to the entire vaccine database. Now, I don't actually know what's in this database because it's too hard to read. It looks like there's vaccinations per million and total boosters. I don't know. So what I'm going to do is I'm just starting. I'm going to say I have a location in the JSON file, and I'm going to try and follow the JSON file down to get some individual data. So what am I going to do? I'm going to look at this, and as long as I'm looking at either a dictionary or a list, I'm going to take one of the items out of the dictionary or the list and look at that. Okay, so how am I going to do that? Well, loc has the same type as either the type of a dictionary or the type of a list. I'm trying to make this fit on one screen. It's not really doing that well. So while I am looking at either a JSON object or a Python dictionary, or looking at a JSON array or a Python list, I'm going to do something. What am I going to do? I'm going to look for something inside of the dictionary or inside of the list. Okay, so how am I going to do that? If the type of location is the type of a dictionary, then what am I going to do? Well, I need to get a key out, and I didn't know a particularly graceful way to do this, so I just figured it out. I created a D, which is a dictionary, and I put 2 things in it. And I needed a way to get one of the keys out, so I was like, oh, isn't there like d.keys or something? Turns out you can't actually just use that. I thought you could say, like, look for the 0th element of d.keys, but you have to turn it into a list as well. How did I figure this out? This is what I did on Tuesday instead of grading your midterms, which I'm sure are great. So that's how you get a key out of. Why can you not just ask a dictionary for an arbitrary one of its keys? I don't know. I didn't write Python. I used lists for years before I found out about dictionaries. That's why I don't know how they work. Okay, so don't put in the course evals. I don't know how they work. Okay, so we're gonna get the keys, which is going to be the list of what is this? Location is of type dictionary, which means I can ask for its keys. And I can take those keys and I can turn them into a list of keys. So this is a list of keys. Then I am going to print the 0th element of the list of keys. And then I'm going to say the location is equal to now the value that is related to that key. This makes perfect sense. Trust me. It kind of feels like when I'm saying that, it sounds like I don't think it makes sense, but actually that did make sense to me. Okay. Lists are easier. You just look at the first one. And then we're going to say loc equals the 0th element. Okay. Then what we're going to do, we're going to print loc when we're done. Okay. Print loc. Which stands for location. Okay. So, oh, look at this. Okay. So the first thing we're looking at in our big file is apparently it's a list of things. Sorry, I meant an array. This is a JSON file. But by the time I read it into Python, it's a list. Okay. So I got a list of things. What do I have a list of? I don't know. Doesn't really affect me. But it looks like there's countries inside that list, right? Okay. And it looks like countries are a dictionary. And then so inside of the country dictionary, there's an Afghanistan. That makes sense. Afghanistan is a country. So fair enough. So what's this telling me? Well, this is telling me something about the shape of the JSON file, and I played around with it a little more. But we have a list of somethings that is dictionaries with a country, that is dictionaries with an Afghanistan. And so what's going on here? We have an outer list of dictionaries. Each dictionary represents a country, has 3 keys, country, and or data, and ISO code. I don't really know what ISO codes are, so I just didn't talk about them. But anyways, there's 2 things. And I think this is because there's not a widely agreed upon language to refer to countries in, so there isn't really a string that represents the name of a country. But there is like a code for like phone things, which I think is what ISO is. Does anyone know what ISO is? It's like International Standards Organization or something, right? So there's an unambiguous way to refer to a country that isn't using its name. Okay. So I have country and ISO code. This is pretty important because I think like at least like in the past couple years, I was aware of a country that I thought was called this. And I'm pretty sure I'm now supposed to call it this. And then there's a country that I think was called this. Now I'm supposed to call this, and maybe there's an accent there. And is that cooked? If you tell me what I'm supposed to write here, I'll do it.
I think it's 2 dots.
There's 2 dots. Oh, okay. On the I?
No,
On the E?
I was thinking there's something on the U, but maybe I don't remember.
Oh, there are 2 dots.
There's 2 dots on the U?
That looks more right.
Yes.
Because then it looks like a
2 dots
smiley
on-
face.
Yeah.
Is the spelling correct? It's Kiye.
Yes.
I just YOLO'd that. That's kind of cool. Okay. This is why you don't refer to countries by their names if you only know one language, because English was cooked. There's like, I do a little better with this with cities. So there used to be a city that I think was called this, and is now called this, and has more people in it than the United States, or like approximately, right? So it's like, it's important to not get that wrong, because that's referring to like 30 million people or like something. And there's at least one other one. So there's I don't know. So like the moral of the story is don't trust things because they're in English, right? And as a rule, you don't know how wrong you are until you're like learn something, right? So try to avoid learning things. Okay. All right. So we've got countries, whatever ISO codes are. We've got data, which is a dictionary representing dates, which specify the date as a string, and some other stuff. Okay, easy. So we can look at one of these. Let's look at vax 0 data 0. Slow. Okay, what do we have here? We're in beginning. We have a date. That's 2021. Good year for something, probably. There's a lot of 2s in this date. Not a very exciting day. There are 0 vaccinations, 0 people vaccinated, 0 vaccinations per 100, and there's 0 vaccinations per 100 twice. Oh, maybe this is how many people are vaccinated that day, and this is how many people are vaccinated in total. I don't know. Maybe we can put like a -1 in here and look at the other end of the list. Oh, that's a little more exciting. It's about 2 years later, right? Many things have happened in the intervening days, right? And so this is a way to look at something. Okay, so we got arrays. And what we're using, okay, sorry, this is a list. It's an element in a list. We know it's an element in a list. Okay, I'm going to print out all of data. And this thing is enclosed in square brackets, so I have a list of dictionaries, okay? This is referred to in some places as like time series data, because it's chronologically ordered, right? And then each one of the entries contains a JSON object. Okay. So there's a few things that can be valid JSON types. You can have a string, like olive drab, but it has to be in double quotes. It can't be in single quotes. But it can be either olive drab or hot pink, which we know are the two strings. It can be numbers, and it can be two different kinds of numbers. It can be the good kind, integers, and it can be the morally deficient kind that we don't trust. They can be Booleans, but they cannot be Python Booleans, okay? If you write capital true or capital false in there, it's going to yell at you, okay? So just don't do it. Use lowercase. Or follow my advice, use 0 and 1, which work in every language, so you don't have to change back and forth. You can do the missing value, and in JSON, it's null. Remember, inspect console. Null is allowed, none is not. Capital T true is not allowed, lowercase true is, but 1.7 is fine. That's not a problem. Okay. So, what is happening? What did I type? Okay. The missing values, and then you can have objects and arrays. Okay. The top level structure of this thing is a list. That's why we say vac0. It contains countries. Inside of each country. Oh, do you like my names of countries? I did Narnia, Wakanda, Gilder, right? Like, I'm cool and fun, right? Gilder, right from Princess Bride. Okay. Countries are objects. They're key value pairs. Country, Gilder, ISO code, GG. I don't know what Gilder's country code is. It's not a real place, right? Data. And then what is data? Data is the key. The value is itself a list. So here I used real and fake countries to demonstrate you can't use single quotes because Elysium isn't real, but you can use double quotes because Cascadia is real. Okay? That's mostly true. If you want to look at this as JSON, you can do this thing called pretty print. Blah, 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 blah. Where's other? Do I want to do this right now? Okay, I'm just going to show you the example on the slide. Here's an example of some summary data I created, and you can json.dumps. So after you import JSON, you can write that out as a JSON file, so you can save it as a JSON file. And here's the string you would write to a file. But you can also make it pretty. And the way you make it pretty is you can specify you want indentation. And this is the number of spaces that are indented. 1, 2, 3, 4. Okay? There's big numbers and little numbers. I don't know. You already know about that. Key takeaways. Use requests to read data from the internet. Use JSON to read data from your computer. You will be using JSON data as soon as you're done with Enigma. This is what JSON looks like. I've named it. This is a planet from Alien and Aliens, right? So it has different population depending on what film you're in. And I label what everything is. And then here's an example of things that you cannot do in JSON that you can do in Python. So, good luck with Enigma. You're going to do great. You have a lot of time left, actually, cosmologically. And then there's only one thing left after that, which is the JSON project. So, good luck.
We go first.